First question. Describe the locus of a point which moves so that the perpendicular distance from a fixed straight line AB is always 4 centimeter. Now, as discussed, locus is basically the path. The path that a point will follow under some condition. Now, it always helps that whenever you see a question like this, you should always underline the condition that the point is following. So, for example, in this case, the condition that the point is following is its perpendicular distance from a fixed straight line AB is always 4 centimeter. So, if I consider this to be a straight line AB, uh, any length, the point will follow a path so that its distance from a fixed straight line AB is always 4 centimeter. It's perpendicular distance. Perpendicular distance. See, one thing that you need to understand about perpendicular distance, about a line and perpendicular distance of a point is that if this is a point P and this is a line L, then the perpendicular distance is basically this distance. This distance. So let me call this PQ. So PQ would be the perpendicular distance. So this point can follow a path so that its perpendicular distance from the line L is always 4 centimeters. So this is 4 centimeter. So can the point come here? No, it can't come here because the perpendicular distance will decrease. I hope you are getting the point. So again, here also the point will have to be here so that the distance is 4 centimeter. If I come here, again the perpendicular distance should be 4 centimeter. Should be 4 centimeter. So similarly, all these, all the all the locations where the point can go is it can only go to locations where its perpendicular distance from the line is 4 centimeter. So if you are getting the point, so this would be the path that the point can move so that its perpendicular distance from the line is 4 centimeter. And uh, if you are thinking with me, what you'll realize is there is another line which is here, where again the point would be at 4 centimeter from the straight line. This distance is 4 centimeter. This distance is also 4 centimeter. Now, because in class 10th we are only limited to 2D, but when you go into class 11th and 12th, you will also study about 3D. So you'll also understand that basically what will happen is that if this is a line L, this is not part of our syllabus. This is just I'm discussing something extra with you. You can ignore this part of the discussion if you haven't understood. If you consider this, see, this is the answer in 2D. So the answer is over in 2D. But if I consider this question in 3D, what will happen is that this would be the path which is 4 centimeter. This would be the path which will be 4 centimeter. But along a line, there will be a sort of cylinder where each of the point in the cylinder would be 4 centimeter from the from this line. So basically, this is how this cylinder, this hollow cylinder, or you can consider it to be a point, to be a pipe of radius 4 centimeter. So consider a pipe of negligible thickness, which is 4 centimeter from the line, and each point on this pipe would be at a distance of 4 centimeter from the line. Now this is for 3D. This is not part of our question, so I'll mark this. This is not what we require. This is not what we require. Our answer has to be in 2D, and our answer would be this pair of line. This pair of line, so that it is at 4 centimeter from the given line. Our given line was this. I hope this is making sense. The difference between the 2D and the 3D. So how will we write in the exam? So I'll also show you what you can write in the exam. So this is what you can write in the exam. The locus of a point which moves so that its perpendicular distance from a straight line AB is always 4 centimeter. Two straight lines parallel to AB, one on each side at a distance of 4 centimeter from it. So you can write this as a answer, and see, if it's a two mark question, then you can also draw a small diagram just to explain. I hope this is clear, and let's move to the next question.